What form is this in? Factor or standard?
Factor.
What form is this, guys? Standard. There's no parentheses, okay? So, at this point, what's my leading coefficient? Negative. My degree is 4. So the ends are going to be sticking straight downward. Okay, I need to factor it, so I'm going to take what out? Negative x squared. That leaves me at x squared plus 4x, minus 4x minus 2. Does everybody see that? Well, normally, it will keep factoring, wouldn't it? So this one didn't factor, so we're going to go to the next one. I won't give you one like that. Number 4. What's my leading coefficient? Negative. My degree. Okay, when it's in factored form, you count the x's. 1, 2, 3, 4. Do you see that? Degree 4. Now let's list the zeros. Okay, so this first one will be x equals what? The next one will be x equals. And then that last one will be x equals what? With a multiplicity of, and what occurs there? Bump. Okay, so let's graph this quickly. Okay, so it's going to go something like this. Okay. Divide. What would I use on this one? Would I use long division or synthetic division? Long division. Do I have all my powers there? No, so what am I going to put in there? 0. I want this 3x to look like 9x cubed, so what am I going to multiply it by? 3x squared. Very good. I'm going to put it above the x squared term. Zero negative 6 gives me negative 6x squared minus x. I want this 3x to look like that negative 6x squared, so what will I multiply it by? Negative 2x. Very good. Negative x and 4x gives me 3x. I'm going to bring that negative 3 down because I need how many down here? 2, because I have how many up here? 2 terms. I want that 3x to look 3x. I'm going to multiply it by what? 1. Negative 3 and negative 2 gives me negative 5. So I would write it 3x squared minus 2x plus 1 plus a negative 5 over 3x plus 2, or you could put minus 5 there. Alright, number 6, we said synthetic. There's no power 3, so I put a 0. Do I put 2 or negative 2 when it's in that form? Negative 2. Negative 2 times 2 is negative 4. Negative 2 times negative 4 is positive 8. Negative 5 and 8 is 3. What now? Oh, that's supposed to be a plus. Yeah, sorry. Negative 2 times negative 1 is 2. I have a remainder of what? So I would write that. I started with x to the 4th, so I'll write 2x cubed minus 4x squared plus 3x minus 1. Now this one, find FC using synthetic. Okay, before we do that, let's look here. Synthetic division, you're going to have to write the polynomial out, aren't you? Synthetic substitution, you just write f or whatever equals that remainder. Do we see the difference between these two problems? Okay. Because if you don't write it correct, it's wrong. Okay. Yes. Okay. If it's in the format like a binomial of like just x plus 2 with a coefficient of 1, that's how you know to do synthetic. If it doesn't look like it, you just use long division. Alright, here in the directions, I'm going to say synthetic substitution. That means remainder theorem. 4, 12, 5. But do I change the sign when it's in this form? No. Negative 1, bring it down. 5 and negative 8 is negative 3. And what's the significance of that? If I did direct substitution, it would give me what? Does everybody understand that? Alright. Number 8, we're just listing the possible zeros. Listing the possible zeros. So I take the factors of, what's my last term? Get factors of 15. Which are what? Plus or minus 15, plus or minus 3, plus or minus 5, and then factors of 2 plus or minus 1 plus or minus 2. Now I'm going to take all these and divide it by what first? And then take all these divided by. So 1 divided by 1 is 1. 15 divided by 1 is. 3 divided by 1 is. 5 divided by 1 is. 1 divided by 2 is. 15 divided by 2 is. 3 divided by 2 is. 5 divided by 2 is. Now, this list, does it give you the possible complex zeros? No, it's just your real ones, okay? Alright. Now, solve the polynomial equations. Let's do this one first. That looks like an x squared problem, isn't it? So you treat it just like that. But instead of it having x squared, it has x to 4, so I'll put what here? X and x squared. It's got to multiply to give you, add to give you 5. What is that? 4 and 1. Okay, since this, you have a question? If it's in that form, can you just move it over easily? Yes. Okay, so it'd be x squared equals negative 4. When you take the square root of something, it's going to be what? Plus or minus 2i. Plus or minus I. On number 9, what is this? A perfect what? Cube. So when the difference of cubed. Okay, when you factor a difference cube, you're going to have a what? And a. Okay, so binomial and trinomial. How do I get the binomial? I take the what of both of these? Cube, okay? Here, how do I get this first term? They do what with this? And then what would last? Okay, then soaps. Same. Here, that would be x equals 2, and then you would use the what formula here. Did you like your review? That's everything on your test. Okay, now let's go back over. Oh, I just want to throw this up here. Read. It says, consider the polynomial function, that cubic, to answer the following questions. It says, rewrite the function completely factor form, where they tell you it's factored, can be factored. How many terms do I have? I have 4. So I would do factor by what? Grouping. Okay, so that's A part. B, it says, use synthetic division to show that x plus 3 is a factor of the function. What do they mean by that? It's synthetic, so I would write that and divide it by, and what number will go outside my box? A negative 3. So what are you looking for to see if it's factored? If you get a remainder of what? 0, that means it's a factor because it went in it evenly, did it? So do you see what that is asking? C, if it does, it says based on your result from part A, can you tell anything from x equals negative 3? Well, if this is a factor, x plus 3 does turn out to be a factor, then x equals negative 3 is a what? 0, isn't it? Does that make sense? You see how that question ties a lot together? Do you think you'll have something like that on your test? That's what I'm reviewing. Alright. Alright, let's look at number 5 from our homework. Alright, number 5. Were there any questions on 6 through 10? What now? Yes, which one?
You know how you said that if our answer, if it's not complex, it should be in the possible roots? Or
that it should be in your possible roots, yes.
What about number 6, how it's plus or minus square root of 5? Like, that's not even possible.
Okay, so that formula is the possible rational roots. Okay. Square root of 5 is irrational.
Okay.
Yeah. But that's a good question. Yes.
What answers did you get from your 10? Because I've got, because whenever you graph it, you get negative 6 and 5 as roots.
And then plus or minus 2i. That was in the video. Did you watch a video?
Not that far.
Oh. It was in the video.
Because that's when I just worked it out, I didn't have to use the quadratic formula. When you get x squared plus 0, x plus 4, you don't have to. You can factor it out.
All right, let's just review what I talked about in the video last night. If you look at the problem and can factor it, do you need to do this whole process? No, like on this first one. I can factor by grouping and get the same thing in both parentheses. So I wouldn't necessarily have to do this. And this one was perfect cube. These 4 you cannot, so you have to do this process, okay? So on number 11, what type of function is that? Number 11, what type? Quintic. And our goal is to break this down to what type of function. Therefore, you can either factor or do what formula? Factor it or do what formula? Quadratic. You can't do a quadratic formula on a quintic because it's not called quintic formula. Okay? Now, how many times are we going to have to break this down? 3. So you're going to have to pick how many zeros off that graph? 3. Okay. So let's graph it. Oh, did you guys borrow my accidentally took my calculator home? I'm not mad if you did. I just need it back because I had. Yes.
I think you got this one wrong. And I said that out of complete confidence. You got -1/3 on the sheet.
I love it. I just love how you said complete confidence. Okay, I'm not perfect, but
Well, because I checked, if she got the same answer I did.
Okay,
You
but
get
I'm probably
-1/3 whenever you work it out. You get 3x minus 1 is one of the factors, which is positive 1/3.
did y'all disagree with mine on number 9 when I got -1/3 should have been positive 1/3?
I got negative.
I'm complete confidence I'm about to work it out.
Yeah, can you work it out?
And then if you're wrong, then we're going to have a heyday with that complete confidence. All right.
I didn't work it out, so I don't see where I got wrong.
I worked it out in the video. I'm sorry, people. Here we go. Challenge. You ready? Now, how do you factor? Do you factor? Which way do you factor? Bus?
Yeah.
Okay, thank you. So let's watch this. Oh, see it now.
So I see where I went wrong. I got -1x plus 3 as one of the factors.
Oh, okay. Hey, that's going to be your quote of the year, though. I'm not mad, but that was the quote of the year.
I mean, at least I had the confidence to say that.
Yes.
There's nothing in there. It's not something we have on students on the manufacturing field trip.
But can I give a word of advice? You better be glad I love all y'all, and I love including you. But before you make a comment like that, should you have watched the what?
Video.
Entirety of the video? You got me? Okay. Moving on. But hey, that will go in my book. I'm gonna write one day. Number 11. You're gonna have a whole chapter, Tyler. All right. Number 11. I done forgot my calculator. Okay. So we're gonna graph this. Alright, so I clearly see there's 3 of them. It's at -5, 2, and 3. I can use my table to check. -5, 2, and 3 to be completely confident about what your zeros are. Hey, you know I'm just picking with you.
Oh, I'm just working it out like you're doing.
Okay, gotcha.
I'm not paying attention.
Alright, so there's our 3 zeros so far. Now I'm going to use this to break down. 1, okay, there's no x to the 4, so I put 0. -18, 30, -19, 30. I'm going to use the first one, -5, bring this down. Should I get a remainder of 0? Yes. Okay. Now I went from a quintic to a what? Now I got to go from quartic to what? Cubic. If already used that one, go to another one. You said, Mr. I started, it doesn't matter, just use, but you can only use the 0 one time. You can't keep using it. 2 times 1 is 2. 2 times negative 3 is negative 6. 2 times negative 3 is negative 6. So I have 1, negative 3, 1, negative 3. So I went from quintic to quartic to what? Now I'm going to go from cubic to, now I'm going to use 3. Alright, now I'm down to x squared plus what? 1. So x squared plus 1. That cannot be factored. That is not a difference of squares. So normally you would use quadratic formula, but here since that's the easy type, you can just bring that 1 over negative 1, so it's square root. So x equals what? Plus or minus I. So your zeros would be, now, what's the maximum number of zeros I could have here? How many do I have? 5. How many is real? How many is imaginary? How many is complex? 2. Very good. Are we good on those types? Okay. Let's do our checkpoint. We're going to modify this checkpoint. It says list the possible zeros. Just find me the zeros. We're just going to find the possible zeros. Now, if you can factor, do you have to do the small process? No. What now?
Did you get
She don't make my decision at the moment.
Did you get plus on this side?
How do y'all feel about it? Let's just do it tomorrow. Y'all ready for tomorrow? Yes. I just feel like that you would have a longer time tomorrow and not. What you think, Tyler, about that possibility?
What, tomorrow?
Mm-hmm.
I think I'll go with one of those questions.
I know, yeah.
That's where he said you didn't have to.
What did you say you were changing about it?
I just want you guys to do the possible, just find it.